Hi, my name is Colin Sisber, and this is Physics 2212 Lab 6 Magnet Molasses. Introduction. The purpose of this experiment was to create an experiment that can find the amount of time a magnet takes to go down a tube, and then also creating a model using data that can predict the time it takes for the magnet to go down the tube. The findings were that the average time to go down the tube was 0.766 seconds, but in the simulation it was 0.838 seconds. The key concepts of this experiment were the magnetic dipole formula shown on top, which was used to calculate the magnetic field generated, and the Lorentz force formula, which was used to find the force generated by the magnetic field. Model. Our assumptions for this experiment were that the tube stays in a fixed position. Scenario, we find the dimensions of the tube and the magnet, and then we drop the magnet down the tube and record the amount of time that it took to go down the tube. Experiment. The first trial took zero point 0.8 seconds. The second trial took 0.73 seconds. The third trial took 0.73 seconds. The fourth trial took 0.83 seconds. And the fifth trial took 0.74 seconds. And here are the results. As you can see in this graph, that the tube was created in, the tube took 0.838 seconds to go down for the magnet. And then here is the code for creating the tube. So, discussion. The average time to go down the tube in the physical experiment was 0.766 seconds, and the time in the simulation was 0.838 seconds. A possible sources of error for this experiment were inaccuracies from recording the time that it took to go down the tube for the magnet, and inaccuracies in the calculation of the magnetic dipole. Conclusion. What if a resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? The falling magnet would fall faster because there would be more current in the foil. What if holes or slots were cut into the tube? How would this affect rain currents in your model? The current would be less in the model because there is less amount of foil to create the magnetic field in the solenoid. Thank you.